Hello, my name is Stefano Fotiu. I'm a partner on the Y project and I work in this European use case. The focus of my work is the modeling in the building sector, and I'm the responsible of the Primes buildings model um, that's been used for this European use case. Okay, the focus of my work in the Y project was the to explore the European use case. This is the aim of this study basically is to explore the possibilities of different energy policies in the European Union that aim to achieve climate neutrality by mid-century. This is in line with the goals that the European Union had set based on their recent energy policy strategies. The building sector itself is a highly heterogeneous sector, which means that it involves many consumers that differentiate with different criteria, either through their income, the location of the building, the type of the building, the age of the building. This means that by default, it's difficult to understand what policies would result in decreasing the emissions of energy in buildings. So the aim of the European use case is to use the Y toolkit or integrate the Y toolkit with energy system models like the Primes buildings model, for example, to be able to understand the impact of different or alternative energy policies that can reach a climate neutral building stock. So the building sector is the highest energy consumer in the EU, and it accounts for almost 40% of energy consumption in the energy system, and it also accounts for almost 20% of the emissions in the European energy system. So decarbonizing the European building sector is one of the key ways to achieve the climate neutrality goal for the whole energy system. As I said before, the fact that it is a heterogeneous sector, it means that there are difficulties to actually find a single policy or a set of policies that will be able to decrease emissions and energy in the sector. So it's important to study in detail how these policies should be designed, or what are the impact of these policies, so that it could be so that eventually the policies that will be suggested or used, they will have the most effectiveness, and both in terms of costs, but also that they will be fair for all energy consumers. Okay, so the Y toolkit uses many different types of buildings or categories of buildings. This is the same also for the Primes buildings model. The model disaggregates the buildings into many categories in order to be able to reflect this heterogeneity that is inherent in the sector. So one characteristic of the Primes buildings model is that it enhances the macroeconomic theory with what we call the barriers to energy efficiency. So for each building or category that the model considers, it associates parameters that reflect these barriers to energy efficiency that can be either true costs or it can be perceived costs. These are quantified in the model and using different case studies or using the bibliography, etc. The fact that the white toolkit disaggregates also the buildings into many categories will be, and it uses real-time data, will improve the Primes buildings model because there can be an interlinkage between the two on how these parameters that the model considers as market or non-market barriers can be reflected through what is given from the white toolkit. So finally, we have from the white toolkit the energy consumption of different types of households and how this differentiates from the average household. And this reflects the actual behavior of consumers. So we could use these relative differences of energy consumption from the different types of households from the white toolkit and translate it into the model parameters that reflect this behavioral or barrier aspects that we have in the model. As the Primes buildings model explores different policies or different pathways to achieve the climate neutrality, it can give an insight on how the different policies may affect the different consumer classes. And what are the costs for each consumer class? What are the benefits? What are the whether the policies are fair or respect the differences between the consumer classes. So finally, the results of the European use case will help policymakers not only to prioritize the different policies, but also to reflect on fairness, let's say, dimension, on the fairness dimension of policies, let's say. The insights that we already have from the European use case come from running the model in its current version for some what we call diagnostic scenarios, and these are scenarios that explore different pathways to achieve climate neutrality in the building sector. And I say with the current model version because after the integration of the data from the white toolkit, there will be an updated version of the model with updates on the parameters that reflect these barriers to energy efficiency. So far, having run these diagnostic scenarios, we see that the decarbonization, the deep decarbonization of the building sector is feasible, and it should focus, or it should, the key pillars to achieve this deep decarbonization is through the renovation of the building's envelope, so with the application of insulation, etc., and the electrification of the heat uses, so the deployment of heat pumps. So what is there to still understand is how the different policies to achieve the renovation of the building envelope and the penetration rate of heat pumps, what are the pros and cons of the different policies to go that road? At the moment, we are trying to create a plugin, basically, that links the energy system models involved in the European use case with the white toolkit. And this plugin will be a standalone tool, and it will basically have two dimensions, like the types of buildings that the white toolkit has, and the energy consumption by energy carrier and energy use in the different buildings. So it will be an Excel file, let's say, with 2 dimensions. This now it's tailor-made to to what the models, the energy system models involved in the European use case need. So for primes and TM, but this plugin will be uh, will be will be easily aggregated or disaggregated into different building classes. So one can do the sums and result in the average household, or it can have all the categories that the white toolkit has, or it may differentiate just with the income. So have the average low income household and the average high income household. So finally, what this will be useful for other models, other energy system models, would be to enhance basically how they represent the consumers in their models. So if someone uses just a representative consumer, then they could use the relative differences that the white toolkit has on the energy consumption and have finally in their model more consumer classes.